Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, we are still with polynomials. We are going to learn how to factor. You already know the sum of two, the difference of two squares. So we are going to learn how to do it to any power. So like a difference or a sum of two cube, a difference of two terms to the fourth power, fifth power, whatever. So let's look at something in the form a to the n minus b to the n, where n is any number, any integer. Let me start with something. First of all, let's do one that you already know. A square minus b square is a minus b times a plus b. Now, let me give you one that is much larger. So for example, let's say, what is a to the 6 minus b to the 6? And you say, oh my God, 6? That's too much, right? No, it's not. You will see that we are following a specific order or a specific pattern that you can expand to any power. If that was 60, not 6, you still can do it very easily. Yeah, believe me. You will have a minus b always as one of the factors. The other factor, because we started with 6, so, and we have an a here, so the next one would be a to the 5th. See what happens after that. Plus, I will drop 1 from the power of a, so instead of a to the 5th, it's a to the 4th, and increase 1 of the b's power. Here there was no b or b to the 0, so that would be b to the 1. I drop 1 from a, increase 1 in b. Decrease 1 in a, increase 1 in b. Decrease 1 in a, increase 1 in b. Decrease 1 in a disappears, increase 1 in b. You can see that it's really symmetric. See how easy it is? But when they were 2, I just wrote a to the first power. I drop 1, so it disappears, increase 1 to the b, so it becomes b. Very simple. How about a to the n, or let's make it m so that they are different. I'm not using the same. A to the m plus b to the m can be factored only if m is odd. If it's even, then you can factor it, but you will have to use complex numbers. What do you mean? Well, let's pick one that you may already encounter. A cubed plus b cubed. 3 is an odd number, so I can do it. Like you might have expected, the first element would be, or first factor would be a plus b. And we'll do the same idea. We are going to decrease one of the, notice this was a cube and this is a. So when I divide them, I get a square. So we start with a square, but then we alternate the signs. Negative, positive, negative, positive. So the next one would be negative. I drop 1 from the a, so it becomes just a. Increase 1 of the b, which didn't exist, so it's b. And then plus. Notice they alternate. Drop 1 of that, it becomes, drop 1 of that, it disappears. Increase 1 in b, it becomes b squared. It only works when m is odd. So I will do another one just to complete it. So for example, I say a to the 5th plus b to the 5th. It's a plus b. Drop 1 from the 5, it becomes 4. Minus, drop 1 from the a, it becomes 3. Increase 1 in the b, so it becomes b. Plus, drop 1, a square, increase 1, b square. Then minus, drop 1, it's a, increase 1, it's b cube. Then plus, drop 1, disappears, increase 1, b to the 4. And now you can expand the sum or difference of any two powers. If it's subtraction, you can, it doesn't matter what the power is, odd or even, you can do it. But if it's plus, you can only do it if the power is up. So now let's take a worksheet here. It has like 10 problems. Maybe, I mean, there is no reason to do all 10. They seem to be the same. So maybe we'll take, oh, they're not, instead of odd and even, they are right and left. So maybe I'll start with left, and then right, and then left, and then right, and then left, for example. So the first one says m cubed plus 27. Since they want you to factor it and this is cube, then you have to write the other one also in cube. So plus 3 cube. So now instead of b, a and b, I have m and 3. But I'm going to treat it the same way. I'm going to say it's m plus 3 times. This is a 3, so I make it m square. And I don't have the b, which is the 3. The next one, I'm going to say minus. Remember, we alternate when it's odd. M, because I'm going to drop one of that. And bring the b, which is 3. So maybe we write it 3m, not m3, right? And then plus. The m drops 1, so it disappears. The negative 3 or the 3 square is 9. Same concept like we did it here. A square minus ab plus b square, where b is 3. Now, do we have that? Yes, we have it, is c. Let's do number 7. So this was number 1. Let's do number 7. Number 7 says c cube plus 8. Well, almost identical. Meaning it's c cube plus 2 cube, a and b. So it's c plus 2. Drop 1 from the c, it becomes c square. Drop another one with the negative, so it becomes c, and bring one of the 2, so it becomes 2. Plus, drop 1 from the c, it disappears. Increase 1 in the power of the 2. This was 2 to the first, so it becomes 2 to the second, or 4. Same concept, but instead of 3, 3 and 3 square, I get 2, 2 and 2 square. So c plus 2, that's c also. Yeah, that's c. Then we move to number 3. Number 3 says 27 e cubed minus 8. Is that the perfect cube? Yes, it is 3e quantity cube. So a here is 3e minus 8 is 2 times 2 times 2 minus 2 cube. But this is minus. Remember what we do with the minus? We say 3e minus 2, and then you get, I'm sorry, we are in the minus. So you do, everything is positive. You start with 3e square, which is 9e square, plus, always plus. You drop 1, so it's 3e, and you bring this times 1, so times 2, meaning it would be 6e. And then plus, you drop 1 from the 3e, so it disappears, and the 2 becomes 4, 2 square. So basically, this is 3e minus 2 times 9e squared plus 6e plus 4. 3e minus 2, 9e squared plus 6e plus 4. It seems like all of them are C, the ones we pick. Okay, now let's move to the next one, which is number 9. G cubed minus 8. So it's G cubed minus 2 cubed, difference of 2 cubes. So it's G minus 2, you get G squared, then you drop the G by 1, it becomes, the power by 1, it becomes G, and you bring 2, there was no 2, so you increase the power to 1, so that becomes 2G. Then you drop 1 from the power of the G, it disappears, the 2 becomes 2 squared or 4. Very easy. G minus 2, G squared plus 2G plus 4. It seems like all of them are C. Don't do that in the test. But I picked ones that were all C's. The last one is number 5. It says U cubed minus 216. That's basically U cubed minus 6 cubed. You have to know the cubes of numbers from 1 to 10. 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000. You will see a lot of them. So the 216 here is 6. 1, 2, 3, 4, 5, 6. Okay, so U minus 6. So that leaves it with U squared. Plus, you drop the U squared, becomes U, and you bring the 6. Then you drop one of the power of the U, it disappears, and the 6 becomes 6 squared or 36. It's really so easy. U minus 6, U squared. No, this is ridiculous. All of them were C. Do you think all of them are C's? No, this one would be B. Would be A. But for some reason, the ones that I picked right and left, the odd ones, it's 1, 3, 5, 7, 9. All the answers were C, which is funny, but that was it. I wanted to introduce the sum and the difference of powers, uh, either like the sum of odd powers like a cubed plus b cubed, a to the fifth plus b to the fifth. They will never give you more than 3. So of course, it's nice to know how to expand to any power, like we did a to the 6 minus b to the 6, or a to the fifth plus b to the fifth. I doubt you will ever get anything more than cube. You see here, all of these were cube. We already know the square, so it's really pretty straightforward. But so that was a short session, but it's important to know how to factor the squares or the cubes or differences and sums. Okay, as I said, as I always say, if you have any questions or if you see that something doesn't make sense or you didn't get it, please let me know. Drop me a line in the comment section. I will try to get back to you as soon as I can. Otherwise, I wish you all the best and hope to see you soon.